start with tangent. You'll notice I have some different points on here than what we did with sine and cosine. I did not do 0 to 2 pi. I started at negative pi and I went to positive pi. That will make sense in a little bit, okay? So when I ask for the tangent of negative pi, think about your unit circle. Negative angles just spin down, so negative pi is over here. That's the point negative 1, 0. Tangent is y over x. So what do we get? 0. Alright. Negative 3 pi over 4. That would be in quadrant 3, so tangent's positive. Reference angle is 45 degrees. What's the tangent of 45 degrees? 1. Negative pi over 2 would be down here. So that's the point 0, negative 1. So y over x, negative 1 over 0 is undefined. Negative pi over 4 is in quadrant 4, so it would be negative. Tangent of 45 degrees, we already said was 1, so that's negative 1. Tangent of 0. Y over x, so 0 over 1 is 0. Pi over 4, that's quadrant 1, so tangent is positive. Tangent of 45 is 1. Pi over 2. It's 0.01. So y over x, 1 over 0, undefined. 3 pi over 4 is quadrant 2. So tangent would be a negative. Tangent of 45 is 1. And pi, y over x, 0 over negative 1 is 0. Okay. So if I plot this, at negative pi tangent was 0. Negative 3 pi over 4 it was positive 1. At pi over 2 it was undefined. What do you think I have on my graph if it's undefined? It's an asymptote. Negative pi over 4 is negative 1. 0, 0, pi over 4 is 1, pi over 2, undefined, 3 pi over 4 is negative 1, and pi is 0. If we think back to algebra, we know that at an asymptote, our graph is just approaching it without actually touching it. So our graph looks like this. How many periods did I graph right there? When normally that would be a length of 1 for a sine and cosine, but if I look, my tangent went up, down, and then didn't it just repeat itself? Yeah, this is actually 2 periods. So tangent and cotangent are going to be a little bit different. The normal period of this one is only pi instead of 2 pi, because that's how long it takes before it starts repeating. When we graph it, we are going to pick the interval from negative pi over 2 to positive pi over 2. So if I just ask for one period, you don't even need everything I graphed there. But if I had just done negative pi over 2 to positive pi over 2, that's a nice interval because we have asymptotes at the end and then just a nice complete graph in the middle instead of trying to do a piece, put an asymptote in the middle and do another piece. So that's why I had you graph some negatives here so we could see that. Domain, we basically see that x can't be negative pi over 2, positive pi over 2, and that list would go on. The pattern just continues, so it can't be like negative 3 pi over 2, negative pi over 2, positive pi over 2, positive 3 pi over 2, and so on. We know it keeps repeating, so you're going to keep having asymptotes. Range, what y values does this hit? Yeah. Okay. Is this an even or an odd function? Remember we talked about that with sine and cosine. Even meant symmetric to the y-axis, and odd was symmetric to the origin. What would this one be? Odd. It's not symmetric to the y. This is an odd function. Symmetric to the origin. So what that means is if you have a negative on your angle, you can pull it out in front. You guys have down everything you need for tangent. Let's talk about cotangent. So this one, I did say, if you look at the points that I'm suggesting we plug in, I did go 0 to 2 pi on this one. We'll kind of see what this looks like. So cotangent of 0, cotangent's x over y, so 1 over 0 is undefined. Pi over 4 is 45 degrees, so that would be 1. Okay, pi over 2, x over y, 0 over 1 is 0. 3 pi over 4 in quadrant 2, cotangent would be a negative 1. Pi, x over y, undefined. 5 pi over 4 in quadrant 3, cotangent would be a positive 1. 3 pi over 2, x over y is 0. 7 pi over 4 in quadrant 4, cotangent's negative 1. And 2 pi is back to where we started, so undefined. So it starts undefined, which means vertical asymptote. At pi over 4 we get 1. Pi over 2 is 0. 3 pi over 4 negative 1. Pi we have an asymptote. 5 pi over 4 is 1. 3 pi over 2 is 0. 7 pi over 4 negative 1. And 2 pi we have an asymptote. So tangent and cotangent are different. Instead of curves, they are more like, not really lines because they're still curved, but they're increasing and decreasing there. Cotangent is always decreasing, tangent went the other direction, it was rising. Again, how many periods did I graph? 2. So what we see is just like tangent, it has a normal period of pi. And so when we set up a normal interval, if I only want one period, we can start at 0 and end at pi. Now the reason I have these different intervals for tangent and cotangent is just so we can graph them a little bit nicer so that the asymptotes fall at the end instead of in the middle. So you could pick a different interval, this just makes it a little bit nicer. Domain, this time we see all our asymptotes happen at multiples of pi. So x couldn't be 0, pi, 2 pi, and the list would go on. Range, we again hit everything here. Okay, would this one be even or odd?
Even.
So it might help if I drew it on the other side. So we just keep following the pattern, right? So even means if you flip it over the y, it overlaps itself. Odd requires 2 flips, so this is another odd function. So cosine is the only even function we have so far. So odd means if you have a negative on your angle, you can just take that negative out in front. Is that okay? So let's start graphing some. Our steps, same thing that we do before. Amplitude is still just a number out in front. Period, we're used to doing 2 pi divided by something. Since tangent and cotangent have a normal period of pi, it will be pi divided by whatever is your coefficient on x. Count by is still going to be the period over 4. Then we'll still do where we normally plotted points, we will put the asymptotes in the zeros and sketch the graph from there. The interval we talked about with sine and cosine, sometimes you need it, sometimes you don't. It can be useful to do it every time with tangent and cotangent just because the intervals are a little bit weird. Anyway, so that sometimes helps people. So I want to graph y equals the tangent of 2/3 x. So what is my amplitude? Amplitude is the number I found, 1. Period is the normal period, which for tangent is pi, divided by the coefficient on x, which is 2/3. So pi divided by 2/3. So that's like 1 over 2/3, so if you flip and multiply, three pi over 2. Count by is your period divided by 4. So 3 pi over 8. Interval can be helpful. With tangent, what was the nice interval I told you we should use? Mm-hmm. So if I'm trying to solve for x, we could multiply everything by 3 over 2. So we get negative 3 pi over 4 less than or equal to x less than or equal to positive 3 pi over 4. So we need 5 total points still. I'm starting at negative 3 pi over 4. Add my count by, which was 3 pi over 8. So negative 3 pi over 4 plus 3 pi over 8 is negative 3 pi over 8. Plus 3 pi over 8 is 0. Plus 3 pi over 8. Plus 3 pi over 8 is 6 pi over 8, or 3 pi over 4. Negative 2 is 1, so we plot the 1 and the negative 1. So the reason we picked this is because it has asymptotes at both ends. And the middle point will be 0. So now we just have to decide, does tangent go up or go down? It goes up. Or if you could think this is like quadrant 4, so it would be negative. This is quadrant 1, so it would be positive. So the negative 3 pi over 4, you'd be at your negative 1. Sorry, negative 3 pi over 8. At positive 3 pi over 8, you'd be at your positive 1. Now when you graph this, it's not just a straight line through those points. Just like everything else, it's curved, and you need to draw it getting closer to your asymptotes as time goes on. Questions? No, not at all. So what's the amplitude here? And what else is happening? Period. Normal period for tangent and cotangent is pi. Divided by the number in front of x. It's pi over 2. Count by, do your period divided by 4 for the 4 quadrants. Pi over 8. I recommend doing an interval every time on these problems. I think it'll just make your life easier. With tangent, we normally go from negative pi over 2 to positive pi over 2. So if we divide by 2, we get negative pi over 4 to positive pi over 4. Add your counter pi. Negative pi over 4 plus pi over 8 would be negative pi over 8 plus pi over 8 is 0. Plus pi over 8 is pi over 8 plus pi over 8 would be pi over 4. Amplitude is a half. So we pick this because we'd have asymptotes on the ends. Zero in the middle. Tangent starts negative and goes positive, but we're flipping it. So at negative pi over 8 would be when you're at your positive 1/2. And pi over 8 would be at your negative 1/2. If I asked for a second period, what would we do?
Keep on adding pi over 8.
Mm-hmm. So far, so good. So amplitude. Period. Normal period for tangent, cotangent is pi. Divided by the number in front of x is just 1, so we get pi. Count by is period divided by 4. What else is going on in this problem? Mhm. You wouldn't have to set up an interval, but it's never a bad idea. What do we pick for the normal interval for cotangent? 0 to pi. My angle is just an x this time. So we start at 0, then we add our pi over 4 every time. Hello.
Just being nosy.
Okay. So then what do we do if we're going down 3?
We're just like, yeah, it's got -2 on the y-axis, -3, and then make a horizontal.
Yeah, we usually just drew in a dashed line there so we can kind of know that's our center. So then, the reason we picked this interval for tangent and cotangent is so that the asymptotes will be on the two ends. And at the middle point, which was pi over 2 here, we would be at 0. Then what does the graph of cotangent look like? Does it rise or fall? Yeah. If you think about pi over 4 is in quadrant 1, so it should be positive. So you go up, our amplitude is 1, so we go 1 above this line. So pi over 4, we go 1 below. Are there any questions for me so far? Let's do one last problem for today. Let's do let's do 2 periods. What's our amplitude? Period. Count by. Interval. Cotangent, we go from 0 to pi. So to get x by itself, we have to subtract pi over 2 from everything. So we have negative pi over 2 less than or equal to x less than or equal to positive pi over 2. What else is happening here?
Up to.
So So for for the interval,
Mm-hmm.
how do you know what's the difference between 0 and pi and the one that has pi over 2?
So if it's tangent, that's when you want to go from negative pi over 2 to positive pi over 2. And if it's cotangent, we want to go from 0 to pi. And the only reason is because where the asymptotes fall. We just pick the interval so the asymptotes are on the ends. Okay. So, my first point is at negative pi over 2. Counting by pi over 4. So plus pi over 4 is negative pi over 4. Plus pi over 4 is 0. Pi over 4. And 2 pi over 4 is pi over 2. Since I said 2 periods, we need 4 more points. Can I just go ahead and add them on? So you just keep adding pi over 4. So we get 3 pi over 4, 5 pi over 4, 6 pi over 4 is 3 pi over 2. Amplitude is 1. We are going up 2, so we need to go to positive 2 and draw in a dashed line there. So we'll be going 1 above and below that. So we pick this interval because then you have asymptotes at the 2 ends. Now, when I say the 2 ends, I mean for the first period. So that was 0 and pi over 2. Where else do we need an asymptote? The end of the second period. And halfway in between those, you're always at 0, which is at our center line. Okay, what does cotangent look like? Does it rise or fall? It falls. So at negative pi over 4, you're 1 above this, and 1 below. We'll just keep the pattern. Are you okay with that? Okay. Let's do these. You can